C itself is not aware of Boolean values, so
Das ist das Ergebnis meiner Websuche.
got freed from Boolean. Hello and welcome back to a new video in my C++ tutorial series. In the last video we have finally got input working, and now we can start our application and input the number that we want. Yay! Do 10. Yeah, 10, 20, 30, 40. Nice. We computed the f for these values. Very, very nice. So yeah, that was all fine, and we made it possible to do this very nicely. And what we also added here is our custom scanx function, which calls the C++ function scanf and also prints some text that you basically need to enter, or a description text that basically tells you what you need to enter. And then it reads the value. So very, very nice. And what it also does, it returns the return value of the scanf and prints the return value out. The return value, basically, to make it simple, just contains a number that shows you how many parameters were actually parsed correctly. In our case, we are just requiring one parameter, so we would always expect getting 1, which is also working. If I add like a 1, yeah, read 1 parameters from the user, and that's nice. If I want to rerun this, it would work for anything else. But as soon as we enter something that's wrong, so something like that, some text that is wrong, it tells read 0 parameters. And you can see that if we read it 0 parameters, you can see that we are basically taking 0 as a default value that has been defined here, 0, and we're doing the computations with a default value. But that's not what I want to do. I don't want to get to default values. What I want to do is I want to stop the application and output an error message as soon as we are getting 0 parameters, or any parameter different than 1, because actually we have this end of file which is -1, so we want to make sure that this is all nice and correct, and we are always checking for 1 parameter. So how can we do this? Well, to do this we need to do a few things. First, we need to shave down our function here, our main function. Just remove everything that we don't need for now. We don't need this because we are probably gonna now print an error message instead how many parameters we got. Alright, so what we will need to do to detect if the result is equal to 1? We need to inspect that variable called result. So we need to compare it with a different integer, the integer 1, and see if it is correct. How can we compare it in C? So first of all, we need to store the comparison. We don't need to store it later, but for now I just want to store it so that we can take a look at it. So how do I want to do this? Well, maybe let's call it check. This is the value that is going to be assigned to. But we always need a, basically we need a type for that. I'm just going to put a plain int here because, well, the result is also an int, so maybe the check is going to be an int as well. Let's try this out. So what I do want to do now is I want to compare the result. And how do I want to compare that result? To 1. How to compare it? Well, it should be equal. How are we doing this in math? Let's try this out. Math. How do I do a math equals? Math. Most of the times I just do it like that. An equation, math, just result equal 1. Right? Then I know the result is 1. Okay? Should work. Let's try this out. I don't want to try this out like that. Let's make a breakpoint here on line 17 to see what we get. So let's start by entering a valid value 10. Okay, you can see we hit the breakpoint, and if we go back to Visual Studio without setting a breakpoint, you can see that the result is 1 because we read 1 parameter, and the check is 1 as well. So I'm assuming that 1 means check is successful. Okay, worked. So I can continue the application, and it's probably going to output the correct values. Okay, so let's run this again and enter some garbage. Okay, enter the garbage, hit the breakpoint, and the resultant check is both at 1. If the result is 1, we read it 1 value correctly, and it should be all good. So the check is 1 again, so we would assume that everything is good as well. I continue the execution, go back to the console, and get garbage. Why do I get garbage? I know. Well, actually, we expected that the result is 0 and not 1. So let's see and maybe figure out what's going on here. So let's make a breakpoint on line 14 as well, so before we are computing the check. So let's start this again with the garbage. Enter it, get the breakpoint. Go in here and take a look at this. Our result is 0. Yeah, it's as we expected. We entered garbage, so the result is 0. Result is 0. Check is an invalid value because that section of code has not run yet. And the 1 is, of course, a 1. So what happens if I now click continue? Well, we would expect that our result stays at 0 and our check gets a different value than 1 because result and 1 is not equal. But what you can actually see is that as well check as result are both 1. Why is that? Well, because the compiler is basically working from right to left here. So it starts evaluating the expression on the right, and then it works itself to the left until it finishes. So the first expression that it needs to do is that expression. Result equals 1. And, well, this is equal to if we would do something like that. If we would assign the value of 1 to result. So our result, which is previously 0, gets overwritten by 1. Now, right part done. Now it's evaluating the next expression on the left. Now it's basically evaluating that. Check equals result. Check is declared here. Okay, so check is there. Check equals result. So result has just been set to 1, is 1. And the value is going to be assigned to check as well. So check is going to be 1 now as well. And as you can see, if we have this line here, this is going to be always assert that check and result, no matter what happened previously, are both going to be set to 1, which is not what we want. So there's an issue that we need to fix. How can we fix that? Well, there's actually just one way to fix it. We need to find a different operator to compare something. This is the assignment operator, the equal. How can we compare something? Well, it's working then like in many programming language like Java, Python I think is not doing this like that, but it's a different story. But Java, PHP, all the nice programming languages, C#, they are all using the double equal to check if something is equal. So double equal in C, C++, Java, Python means compare these two values and make sure that they are the same. So now let's try this out again and start that here again. So now enter something valid like 10. And we are hitting the breakpoint, and the breakpoint is now gonna tell us, okay, the result is 1, the check is at some uninitialized value. If I continue, the result stays at 1, and the check goes to 1 as well. So comparing both values, and if they are the same, seems that it still stays at 1. Let's try this out again by putting an invalid value in here, so some text here, pressing enter. Now you can see, alright, result is 0, check is still initialized. If I continue, result stays at 0, checks becomes 0 because the comparison is unsuccessful, not equal. Alright, so 0 and 1 are the two values that we can get from that binary comparison. 0 means not equal, 1 means equal in this case. Or, to make this a bit more simplified, this is a Boolean expression which results in a Boolean value. The Boolean value in C is not a real Boolean value. The Boolean value in C is just something virtual that can be stored wherever you want to have it. In our case, we are storing it in an int variable, and since we are storing it in an int, this means that the binary value, the binary comparison, that Boolean value 0 or 1 gets converted to an int and stays at the same representation, so is 0 or 1 operator, and then the result of that comparison is written as a Boolean value. In the case of equal equal, it means that we are checking for equality, so the Boolean value is going to be 1. Here, the check value is going to be 1 if the comparison is okay, so both values were the same. But what we could also do is not equal 1, or for example, not equal 0. Not equal 0 would do the same that we had previously. Okay, taking for granted that the result is returning 0 or 1. So if we would do this like that, we would get the same thing, because like, okay, now the result is 0, but we are checking that it is not equal. So if they are equal, it is actually false. The Boolean expression is not correct, so it is 0. And 0 and 1 on Boolean types is always going to be determined as true and false. False representing 0 and true representing 1. C itself is not aware of Boolean values, so
Das ist das Ergebnis meiner Websuche.
So in the case of the not equal, basically, we are checking 0, not equal to 0, no, it's equal to 0, so the result is going to be 0. If it would be something else, like 1, okay, 1 is not equal to 1, okay, true. So we can kind of like, okay, 1. So what we can kind of like do is we can change this operator and change what 0 and 1 means. We can also compare things. We can use these pointy brackets, I don't know how they are called, like comparison symbols. These one, we can use them to compare. So result smaller than 0. Result bigger than 0. Bigger equal than 0. Smaller equal than 0. Not equal 0. Or equal 0. Or in our case equal 1. Because we could still have that end of file. So not equal e of something like that would work. Like, okay, that works. And we can basically now, in our case, we just want to set it equal to 1. Because our only valid outcome is 1 here. And this is the so-called Boolean expression. Left-hand side, right-hand side, operator in between. You can also chain Boolean expressions. So this is basically one Boolean expression, and you could chain them together. So what we could basically say is not equal to 0. But not equal to 0 does not contain the additional end of file condition. So what we can basically do is we can chain multiple together. So in this case we need two. We need to check if it's not equal to 0, and we need to check that this is not equal to end of file. And we can chain them together by putting a double ampersand. Double ampersand means logical and logical and is also a Boolean expression, or a Boolean expression here as well. So basically what we are doing here is we have a big Boolean expression with a left-hand side, a right-hand side, and an operator. The operator means kind of like and. Both of them. So this operator means, alright, this needs to be true. So this means, this and basically means the left-hand side needs to be 1 and the right-hand side needs to be 1. And from now on, I'm going to say to true to 1 and false to 0, because Boolean 0, 1, yeah, nice. But we like to, if we talk about Booleans, we like to talk about true and false. True means the expression is true, like the check that we have done, it is true, it is valid, so we're going to say true, or it is false, it is false. It's just a bit of something that you talk about. True and false, it's just a language construct. The computer's not aware of it, it still treats it as a 0 or 1, but true and false is something that we like to talk about. So this expression basically means that the left-hand side and the right-hand side needs to be true for the full Boolean expression to be becoming true as well. So in our case, we need to evaluate the left side, which is in itself, again, a Boolean expression. So result not equal 0, left-hand side, right-hand side operator, and the right side here, left-hand side, right-hand side operator. So this one is basically the same, only in our case, then result equal 1. The advantage of that expression here is basically that it is universal. So this expression really doesn't depend on how many parameters you are reading with the scanf. This is going to always work. So this expression always works, but the only quality this expression has is, was one or many valid values read. If we are doing it differently, if we are doing it like we did it previously, this is having a bit more quality, but it's also more restricted. So now I'm restricting us to just one value was read. If 2 values were read, it's going to fail. If no value was read, it's going to fail. If we had end of file, it's going to fail. This one, it's a bit more graceful. It is only going to fail if we didn't read nothing or we had end of file, but it doesn't care how many we read. This is something that you probably want to use if you're having some default values, for example. If you're having some default values, and then it's probably fine to just check with that. Then you can basically check and see, oh yeah, I got at least one valid value, I need one valid value, and the other ones are then, for example, if you have a default value of 0, they're just going to be 0 and not be summed together, for example. Or, of course, they are going to be summed, but they are 0, so they don't have an impact getting summed together. And the check would be just simply on that one. But in our case, we want to use the long version. One thing that I want to show you as well, like this is an AND, both of them needs to be true. And this is an OR, so one of them needs to be true. This one means OR, 2 more times the kind of like, yeah, I don't know what this character is. Pipe symbol, I don't know, means OR, and this means AND. What you can also do on Boolean expressions is you can invert them. So I can basically see equal to 0 and equal to end of file. This would now basically contain the fail condition, but what I could do basically is I could invert both. I could basically put an exclamation mark before that bracket here. This bracket, by the way, is only required if we have that exclamation mark, but what I would always recommend is that you always put each single operating Boolean expression in brackets. to make sure that they are chained correctly, and you can add an exclamation mark simply. So basically by putting this exclamation mark outside of here, we can basically invert the value. So in this case, we are still checking if it is equal to end of file. Okay, it's false, but then after that result was evaluated, it's going to invert this. The nice thing is that you could add multiple things into here. We could do something like that as well. So you could say result equals to end of file, or result equals to -1. Invert the whole expression. So this is going to be true as soon as we have one invalid parameter. And as soon as we kind of like invert this again, we are basically having the same that we had previously by chaining them together with AND. And as you can see, you can put the brackets here how you like. If you do something like that, it's totally fine to not put brackets in here, but we need to put one outside of that to make sure that we invert the whole expression. You could also do this like that, would work like a charm, would do this like that, because it's basically working from the inner to the outer bracket. So it's evaluating that one, chain these two together with that big bracket and then inverts it. What would not work is something like that. That would not work, because this one is actually just inverting the result. It's trying to invert the result. If you are lucky, it might invert the whole expression, but that's not something that I want to do or would recommend to do. So at least if you have an exclamation mark, always make sure that you put the brackets, because the brackets are going to tell the compiler in which order stuff is going to be executed. From the inner to the outer bracket, it's going to be executed, and you need to make sure that you are getting the right result. But in our case, we're just going to check the plain equals to 1 again, and we are fine. Now it's all good. Now we know how these Boolean expressions work and how this all comes together. Now the only thing that's left to do is we basically need to check if the check is true or 1. How can we do this? We are doing this with control blocks, and this is what the video is going to be about today. So what is a control block? A control block is a block that is only being executed when a condition is true. So basically, all this code that we have down here, we only want to execute this code if the check is true. And it couldn't be easier than that. If check is true, true is implicit here, we want to do that. Now, if you would want to try to compare this, you can also compare this here to 1 again. But basically what you're doing here is you are comparing that integer. If that integer is 1, and then it's going into a Boolean expression. The Boolean expression, if, which takes a Boolean expression in here, is always going to check at 1 by default. So it's always going to be checking for 1. And you don't even need to store the check. You can just do it like that. Result equals 1. Or you could even go even further and get completely rid of that and just say if scanx equals 1. Or even further, just if scanx. Because if it's not, it's going to return 0. Or -1. -1 could screw us up here. So we're just going to make sure that it is compared to 1 first. Because the -1 or the end of file, whatever value end of file is, might screw us up. So in this case, we should still make sure that we have that 1 in here to basically make sure that we are checking this. If you're having a value that can be always just 0 or 1, so an actual real Boolean, it's okay, but you have this int here. We have this int here, which needs to be 1, so in this case I need to have the checks in here. So if, open brackets, scanx for x equals 1, do that code. What do we want to do if this is not correct? We want to do something else. So else, if this is not valid, print f the input must be a number. And that's all what we need today. As you can see, very simple. If scanx equals 1, the input must be a number. Run this. Again, like that. Enter the value of x, 5. Does it job? Run it again. Enter lol. The input must be a number. So as you can see, it works like a charm. We can take this if block, just a keyword in the language, and a Boolean expression in these brackets, and as soon as this Boolean expression, the full Boolean expression, returns to true, the code under if is going to be executed. If the code is false, this is executed. You could go even further and do this a bit more intensively. You could do this like that. You could say int result equals to that. And what you would basically do is you would check it for 1, and you would execute the code. And now what you would now want to do is you want to now, on the else tile, in the else section, you might want to now check what the actual error is. So if the result equals end of file, you would say something like printf IO error. Something like that. And in the else tile, if it was not end of file, so it was 0, or any other value which would later on be something else, if we have multiple arguments, we would say something like the input must be a number, right? If we do this like that, we are now getting a bit more control. I don't think that I can really provocate the end of file error. I can do, but not really correctly. Input must be a number. If we can get the end of file error, I'm just gonna say result equal end of file, and if I would do this like that, we can also represent this and getting the IO error here. But that's not what we want to do yet. So we can also chain them together like that. But as you can see, this is like a bit of a mess, right? Having the else and in the else and if again, not really what I want. But luckily there is a way around that. Let's just move this out of here and put this to there. You can do an else if directly. Now we can grab the full else and move it one level up. So this actually works. Can do something like, yeah, if result is end of file, okay, IO error. And if it's something else, now we already checked for 1, we executed our code, we checked for end of file, we print the IO error. And if it's something else, we just have an invalid number of arguments. Input must be a number in our case to check this up. And this makes this way more readable, just having that at one level. And this is something that I would really recommend, that you always keep the same level of checkings at the same level in code, so that you can see this very simply. And now you can see that our function is a bit overgrown. So what we're going to do is we're going to define a new function, and we're going to define this new function called, we're just going to call this execute computations. And the value is going to be the x that shall be passed, and this function shall execute the computation. It does not need to do something, it just should execute. Maybe not execute, maybe execute and print. This is a bit more meaningless than name because it's printing. Execute and print is the function that we care about. So let's put them in here. Void execute and print. And as an endless execute and print, we're just gonna put our process and output, which the comments we're just gonna now get rid of in the future. And I can say execute and print for our x value here. And then we're just gonna paste that down here. And now let's just get rid of the IPO here. And now, int, like that. It looks nice. Now if I run this, take a look at this, it's looking a bit more clean. Like if the result is 1, execute the print. And if the result is end of file, we give an IO error, or else we say the input must be a number. And that's fine. So yeah, that looks very nice. Let's press F5 and see if it still works. And maybe let's say 20. Yeah, seems working. Let's run this again. Add some code in here. The input must be a number. Works. I did saw some output here in the build. Where is it? Why? I saw they got some errors here. Let's rebuild this quickly. Let's see. I wanna say rebuild simple C. What is that? Conversion from int64t to int32t. Oh yeah, because we have, okay, this wasn't a 64-bit int, this was a 32-bit int, my bad. So let's change this here, and now this shouldn't give us some messages. All right, so now it's fine. So as you can see, all right, we are printing it. Good, that's nice. But I'm still missing something actually. So what I actually miss is controlling how many times we wanna print that. And we're going to talk about that in the future. So in the next video, we're going to make sure that we are computing and printing exactly as many times by multiplying as we want. So this was the if statement today. See you in the next video. Make sure to like and subscribe, and I hope you enjoyed. Have a nice day. Bye.